It's 7 a.m. Pacific. And that means it's time to start the streams. All right. Okay, where I left off yesterday. We have a spinning cube now, but we also have a spinning ground, which is not what we want. We want the ground to be fixed in space, not rotating with the cube. I think it has something to do with the fact that here's where we write the rotation for the cube. But it's done for every model. If I show you here, for every model it's drawn. We're supposed to be using the rotation for the model. So the model's rotation, but it ends up using the cube's rotation instead. I think the problem is that Q write buffer followed by draw indexed, followed by another write buffer with a different set of values, and then a draw index of something else, that the first write buffer is sort of dropped. So to test that theory, I think what I'm going to do first is where we do the draw commands, somewhere inside of here, this draw. Where draw calls the draw for the models, where these models are constructed. Where are those models constructed? Right here. What if I change the order of these? And I put the ground second. I could be totally wrong about this theory. Maybe something else that's causing the rotation from the cube to be used for the ground. Yeah, now it's not drawing anything. So the entire transform, probably of the ground, is being used for the cube. So where do I set up the ground transform? Here's the cube. Okay, so it's that we moved the cube out. So, and I didn't move the ground out. If I did, I betcha it would, if I applied the same transform to the cube and the ground, I bet we'll see the cube again, but it won't rotate. Right. We're also not seeing the ground underneath it, which is not right. So I should at least see the ground from this angle. So I might have wound the vertices for the ground incorrectly. Let me fix that. So these are the ground vertices. -10 for the x. -10 y. Oh, that's right. The sign of the z or z coordinate needs to be reversed. Yeah, I realized that yesterday at work that, oh, I had right hand rule z or z is positive coming at us, not going out. So if this is the front left of the ground, that should be behind us. So positive z. Hey there, Epic Unknown. How are you doing today? I'm trying to fix the ground. Oh, there we go. Fixed ground. So because our camera angle starts out looking straight forward, the ground is as it should look. When I start if I do the rotation of the well, hold on. Yeah, if I flip the order, where is it? If I flip the order, draw the ground first and then the cube. Now I think it's going to rotate the ground and the cube together, even though it only should be rotating the cube. At least we should see the ground at the start. We should see the ground rotate right immediately. Yeah, see there? So there's the ground. And the ground is rotating with the cube, which we don't want. Hey there, Cube Sudor. What a coincidental name you have. This is also a cube, but it's not a Sudor. Okay. I think I need to do some research because I need to find out why it is that when I am writing a buffer to the queue, drawing one thing and then writing a different set of values to the same buffer and then draw again, that the values we're writing to the queue aren't actually used for this draw. They're like, it's whatever is written second is used for both. Hey there, dude, man. That fish makes me laugh. Okay, so time to do some research, I guess. Maybe start with the tutorial that I was following along. That wasn't it. Did I not keep a tab open for it? It was like learn wgpu is the tutorial that I was following. Here it is. I think I want to look at this uniform buffers on a 3D camera. Remember NixOS? No, TSJoss is, well, TSJoss is almost right. He said it's X Ubuntu. It's actually just Ubuntu. Is it XFCE? Yeah. And I'm running XFCE for the desktop. So it's just vanilla Ubuntu. It is on a ARM architecture because I'm running this on a Mac Studio in Parallels. I want to get to where they're talking about loading the buffer. Look further down in that window. Okay. Oh, distributor. Distributor. So I should not be reading OS name. I should be reading distributor. I don't even know what Xubuntu is. I just know I went to the Ubuntu website to download it. Oh, that's with you with XFCE. It becomes Xubuntu. So they're like glued together. Okay, I learned something today. Uniform buffer. So it's a blob of data that's available to every invocation. Right, but what if I want a set of values that apply just for one instance? Maybe I'm not supposed to be using a uniform buffer. Lubuntu? I3W Ubuntu win. Kumbuntu is KDE. Okay. So the uniform buffer is associated with a bind group. The true, you'll have to supply the offsets later. Okay, so I was just thinking that if it's true, we can only have one uniform per render pass. Then, hold on, let me show the... I shouldn't talk until I have something prepared. If it's true that we can only have one value for the structure for the whole render pass, and right now I just have the transform for one instance, maybe the solution is I put an array of transforms and then somehow get hold of the instance number. We should be able, there should be per instance data. I think that's actually what I'm supposed to be looking for, right? I want per instance data, not uniform data. Maybe I need to go down to the instancing here and read about this. What if we wanted more objects? This is where instancing comes in. This talks about drawing the same object, but what if I want to draw two different objects? This talks about updating it before we draw each instance, but that's what I'm doing and that doesn't work. Updating the uniform buffer for each instance would require multiple buffer copies for each frame. So I could do that, but my first attempt didn't work. Okay, our method to update the uniform buffer currently requires us to create a new buffer to store the updated data. So maybe that's the problem. I would have needed to create a new buffer, not update the old one. Look at the parameters for draw index. You see the solution of our problem. Instances takes a range, how many copies, blah, blah, blah. Okay, there's an instance buffer. We'll create an instance buffer. Okay. You see, they're just doing what I'm doing. They don't put the I'm not storing it as a different position rotation because it's more efficient to store it as a matrix too, especially if you have like 3 or more transforms. Okay, so it needs to go into a buffer. Create the actual instances. Okay, to create the actual instance buffer, they create the buffer the same way, right? Create buffer init. Usage is vertex. Okay, is that the difference? Usage is vertex. I think for my uniform buffer, the usage was uniform or something like that, right? Let me look. It would be in wgpu init. No. Render setup? Okay, it should have been in one of those two. Is it not in here? Maybe it's in model renderer new. There we go. I should close that. Okay. Here's where we created. Okay, we have usage uniform. Maybe what I should be doing is put vertex there. Allow buffer to be a uniform binding in a bind group. Wish it would have a little bit more information about what it means for a buffer to be inside a bind group. But, you know, we'll figure it out. What's copy DST mean? Allow a buffer to be the destination buffer for a copy buffer to buffer, copy texture to buffer, clear buffer, or write buffer. Well, write buffer is the one we're using. We're using that down in draw here. Back to the documentation here. So they're making a vertex instead of a uniform buffer. Now, how do they use it? Vertex buffer layout. Do I not have one of those? Need to switch from using a step mode of vertex to instance. Oh, there's a step mode. Okay, so rather than making a uniform buffer, I can make a vertex buffer that steps per instance then, right? Put my stuff in there. And then add it to buffers with the vertex state. Okay. Hey there, Zeronox, how are you today? Am I creating a vertex state? Yes, I am. And right now I'm putting the vertex attribute buffer description in there. So along with the attribute descriptions, we'll put the instance, I don't know what to call it, like instance uniforms? Okay. Okay, so it's set vertex buffer like I had been using. But it's a different bind group. It'd be 1 instead of 0. In the middle of learning to rush yourself, consider doing AOC. Do it. That's what I've been doing. I missed last year, though. Not sure when to start abstractions in the latter case. When you're building something. What do you mean by start abstractions? You mean learning how to do traits? Here, let me show you an example of a trait I'm using in this project. So I want my test program here. I'll show you what it looks like since you just joined. I'm trying to draw a 3D scene and add physics to it, right? I currently have the problem that the ground rotates with the cube. The ground should be fixed, but let's ignore that for a moment. So you see how it's doing W init window for the top? If I run it with full tick instead, now it's a full tick window. So full tick and W init are two different ways to get to make windows in Rust. So if I wanted to use both and not have to do a lot of duplication of code, I'd like to put the common code in the main part of the program and put what's different between full tick and W init in separate implementations. But then the kicker is I want to choose it at runtime, not compile time. So the way that I did it, this might not be the best way, but I defined a trait called abstract window. And here I put into all the functions that are different between those two windowing libraries, right? How to create a surface, the actual event loop, how to get the size of the window, and getting access to the context and integration for egui. And that's because those are tightly coupled with the event loop, right? So you make that trait. Oh, I actually had to have a second one because the implementation needs to split into two pieces that have two different responsibilities. One is the overall window, and the other one is dealing with the integration itself. And that's how we break it off. We actually get it out like that. Anyway, so once I define the trait, that's the abstraction. Then I can define the two implementations. So W init one looks like this, where you say implement. That's not the right one. Implement abstract window for W init, and then here's how we say, like, how do you create a surface in W init versus how we create it in full tick. The code looks the same, but what's different is the type of this window. In full tick, it's a full tick single window, right? But for W init, the window is a W init window. And then the event loops look radically different. So things could look either similar or just different by types, or they could look radically different. Like the full tick event loop looks a lot different from W init event loop, right? So there you go. There's an abstraction. You ended up abstracting everything into structs before you need it. You're spending too long perfecting your abstraction before you even use them. I don't think abstracting everything is that bad of a thing. It's just maybe unnecessary indirection. All that abstraction really does is it separates the type system into there's like a separation point where actually I should show you where I do the selection in my main, right? Main. Where are you, main? So right here, right? Basically, when Rust compiles this, knows the concrete type of most everything, unless you use these abstractions, right? These with the dyn keyword, you're saying it's some type that dynamically implements this abstraction, this trait. So Rust can no longer it doesn't know as much about the actual type. The only thing it knows about is that through a pointer at runtime, it will be able to get to the functions that the trait requires, right? Otherwise, the type is, I think they call it, the type is being erased. So all the advantages in Rust about the type system can't be used other than the trait, right? You're narrowing down the usefulness of the type system. That's the bad side. The good side is that I can now create two different types and feed it into the same variable. You can't, normally you can't do that with a match. Normally with a match, all of the match arms have to yield the same type, but here they're actually yielding two different types. It's just the differences between the two types are erased, and that now they look the same because they're both a dynamic type that implements abstract window. So if you did that for all your structs, you'd be erasing all your types, so you'd be losing a lot of the advantages in the type system, like a lot of the efficiencies and performance benefits. But then you gain this flexibility at runtime where the actual values can have different types under the hood. So I think what it comes down to is you compare the pros and cons with that. So for me, the pro was that all of the code after the window creation can be the same, no matter what kind of window I made. And that's pretty significant because that's most of the program, right? If maybe you only had you made an abstraction and you only used it to call one method, it wouldn't be as advantageous. You might as well use a generic, because then the compiler will generate two different method calls that like two separate sets of code, one for each type, that you use branching rather than a pointer at runtime. You have more enums than lines in your main at the moment. You just gotta do it, you guess. More enums than lines, huh? The enums is a different thing, right? Enums is not an abstraction. That's a variant. That's telling the compiler that this value could have one of many concrete types, but it's bounded. It's no longer abstract. I wouldn't even call it an abstraction. That's more of like making a union than making a class in C++, right? So you're listing all the things it could be, not saying that it could be anything that agrees to a contract. I don't know why, but recently I've been like explaining things 3 different ways, and then I'm like, why did I just explain that 3 different ways? I could have just said it once, and then if you had any questions about it, then I could explain it a different way. Right, I was going to look at where I call set vertex buffer, right? Yeah, so I guess what I'm doing is I'm setting 2 different buffers. One that steps per vertex, the other one steps after the instance, which would be, we're only drawing one instance anyway, right? So there'll just be one of it, which makes sense, right? So we'd have a array of size 1 of vertex transforms. I would be nice to know how to get it to work the other way with uniforms, because they suggest it could be done. Way at the top here, right? They say one way would be to modify the uniform buffer and update it before we draw each instance. That's what I tried to do, but it didn't work. So it would be nice to know, like, if it could be done, how do I do it? It's really hard to know in a stream if the other side understood it or not. Maybe that's why I'm explaining it. It's like I'm explaining it, and then I don't get any cues about if I was understood or not. So I'm like, let me just assume that you didn't understand that, and I'll explain it a different way. You guys tell me if it's too annoying, and I'll like, okay, that's fine. I'll just explain it once, and I'll just assume you understood me. I want to, I guess, do a search to see if someone else has run into this. wgpu update uniforms for every draw. Best practice for per draw uniform data. Here we go. This is probably too zoomed out, so let me zoom in. There, it's easy for you guys, and it's easier for me to read it. Of course, it's a newbie question. Newbies ask lots of questions. Let me guess, it's the same tutorial. Yep, it's the same tutorial. Push constants. There's a thread saying, what does push constants mean? Oh, per object uniform data. It doesn't seem like it's possible to have uniform data per object draw. I'm guessing it can be done if the offsets are passed into set bind group, or if there was access to push constants. Another way to have per draw uniform data. The group has not yet accepted any push constant semantics. In short, it wasn't clear how to best expose them. In all cases we've seen, using push constants wasn't required to get the job done. One worker has used dynamic offsets like you mentioned. Dynamic offsets. We look and see how it was, what dynamic offsets means. So it's a sequence of dynamic offsets. And how do we use these dynamic offsets? What's BS? What language is this? This is an interface description language of some kind? Huh. Oh, because this isn't Rust. This is wgpu. Cool. I lost my place in this. Let me close that tab and open it again. Okay, there's where we were. I guess it's just pointing out that there is something called a dynamic offsets, but it's not exactly describing what it means, so it doesn't really help me. Hey there, Metalstorm. Said that Prime stream yesterday that you can't stream your game development because of your job. Yeah. So there were basically two big conditions of me streaming while having my current job. Number one is I can't do game development. Actually, there's three of them. Number one, can't do game development. Number two, need specific approval for open source. So basically, I can't upload my code to GitHub or anything, right? And I can't work on open source projects. Number three is I need to steer clear of anything work related. So I can't talk about or show me coding or have a discussion about anything related to my actual job. So I don't do Rust at all at my job. So I figured sticking to Rust and like playing with Rust libraries or doing admin of code with Rust or teaching about Rust is all perfectly fine because it had nothing to do with my job or what I do at my job. Rust is a completely different paradigm, though, than your previous experience. It started 5 years ago in web dev. Thought with the borrow checker. Okay, you know what I learned, Xeronox? The tutorials in Rust, right? If you go to rustlang.org and you go to learn and you either go read the book or you go through the course, my opinion is that all of these thrust you into the realm of borrowing, references way too fast. And it's actually very different to borrow or get a reference in this language than others. There's a lot more restrictions and responsibilities you have. Just out of curiosity, I wonder how fast they actually, like, when do we first see a reference in the examples here? So we're just talking about values, so we don't have references yet, so that's good. So maybe the Rust by example isn't so bad. No references yet. Probably none of those use references. I bet as soon as we get into functions, they'll use references. No, I'm wrong. So this is the learn by example is actually pretty smart because they don't introduce references yet. Maybe in flow control. Nope. Okay, maybe Rust by example is a great start to avoid the stickiness of learning references and borrowing. I bet when we get to generics, though, we're going to have references. Oh, I'm thinking it's because I'm only looking at the first page. What if I go to second page of functions? Yeah, so right away we have a reference. And not only that, but they don't actually talk about references and what it means. So I think this is actually a kind of a big mistake that a lot of people don't talk about in teaching Rust, is when you start using references, the first time you use it, you should explain what it means, and this doesn't. You couldn't agree with those restrictions? It's like saying you can't do any of your hobbies. I figured that I still have a subset of my hobbies that can meet those restrictions, and so I'm okay with it. The alternative would be to find another job, but I kind of like my job, so I'm happy with it. I've reached an understanding and compromise with it. It clicked after a week, but seeing as I had no experience, so Zeronux, you may or may not have the same experience, but for me, I thought it clicked until I started to do some more coding in Rust, and I kept running into these weird borrow checking issues, and then I realized it didn't really click. I had a misunderstanding of what a reference was. I think what it was is this at, I should zoom in so you guys can see it better. And maybe, can I, well, I resize that? I can. This symbol, this ampersand, I was familiar in C and C++ for it to mean that give me a pointer to the thing, and that's it, right? And then I'm like, when they went through the explanation of lifetimes, I'm like, okay, well, we have lifetimes in C and C++ also, but it's sort of our job to make sure that we don't use a pointer after it's no longer valid. Like you call free, or you get a pointer to something on the stack. You don't use it after that, after the stack pops or you free it, right? You don't use that pointer. But there's a lot more to it in Rust, and especially when you take a reference and you start passing it into a function like this. It requires sort of a different way of thinking about it. And I don't like that they don't even touch on it at all in this. They just jump to it. I would have rather have taught an example of a function by just removing the reference completely. Because probably in their example, they don't do any loops or anything, so there's no reason. Yeah, there's no reason to not to just have area return an area of a triangle. And don't borrow the rectangle. Don't borrow the rectangle. Just consume it. Like it could have been structured differently, you know. So basically, they make rectangle of value type, and I don't know. Maybe I'm over explaining it again. But yeah, I think there's still some aspects of the borrow checker that I still don't completely get, but when I start thinking about it differently, that sort of like the lifetime of a borrow is part of the type itself, and not just like an added on restriction that, oh, you can't use this pointer after a certain point. No, it's actually part of the type. So if one borrow has a different lifetime than another, they are actually different types. Just forget about borrowing until they get all the other basics. So yeah, what I've heard a lot is sort of like a joke, but to avoid borrow checker errors and borrowing, just do clone. You clone everything. So every function consumes the value. So if you want to use the value twice, you have to clone the value so you get 2 copies of it, and then you can call 2 functions, and that's it. Or you can clone it right before calling the function. Or another trick is you can have a function consume the value, but then return it back out, kind of like an assembly line where the value goes in on the input conveyor belt, but it also comes back out the other end. Yeah, the joke of like just clone everything to avoid the borrow checker is actually kind of a legit way of doing things at first. Types and functions that borrow other things, yeah. Built a demo Rust app doing the exact thing to prove that it would work just fine and learning it was quite easy. Exactly. So I did a course on how to, I did a course to try to teach introductory Rust, and I might go back through those videos and maybe record a new one that kind of concentrates on that subject, saying like you really need to be careful when you're learning about references and borrows in Rust because they're different from other languages. Your knowledge you carry from C to C++ doesn't really carry exactly, doesn't translate exactly 100%. And maybe say like until you really get it, have in your arsenal off to the side, clone everything if you need to, pass things back out that you passed in if you need them again, those kinds of things. Not really written with the borrow checker in mind, yeah. See, if Sarian says it, it's got to be true. Because I mean, anyone whose name is physically etched into my keyboard is got to be legit, right? Okay. Back to this. So this is talking about dynamic offsets. I don't quite understand that. I don't think I need to read about it completely. This whole subject was about per object uniform data. Okay, that was the end of that. Yeah, I'm with this guy. It's not clear to me how changing offsets into the buffer will allow me to pass arbitrary matrices, right? So yeah, I'm in the same boat. Push constants with mapped buffers. I don't know about that. wgpu doesn't offer a solution that would be obvious to use. The closest thing you can get to obvious solution is push constants. Here's how you do it in a portable way. You can't do any transfers in the middle of a render pass. See, I think that's what the conclusion is. That's what I was trying to do. Transfer a new set of uniforms in the middle of a render pass. It's not allowed. Transfers are done on command encoder outside of a render pass. Therefore, each separate object that you draw in a render pass needs to use a separate area in the GPU buffer somewhere. It needs its own matrix. That means all your data has to be ready by the time a render pass starts executing. So let's see if they end up doing the same technique of putting it into an instance step vertex buffer. Oh, no, they're using the offset thing, right? They're writing in at a certain offset and adding to the offset. Okay, well, I don't really like that idea. I like the idea of it's really tied more closely to the vertex shader, right? So why not just make it a vertex buffer? You tried Rust, you converted old C program thinking it'd be a good exercise. Turned out to be a mistake as it just set you up for borrow checker frustrations. Well, a good rule good rule to follow when converting an old C program is don't use borrows at all. Use pointers, because that's what you're dealing with C. So you're going to end up making an unsafe. Everything has to be marked unsafe. Maybe every single function is unsafe. But you can do it. Just deal with pointers. At least I thought so. Maybe the syntax gets a little unwieldy if everything's a pointer. Rust got rid of memory management so we can manage the borrow checker. Yeah, it's almost like it's disingenuous to say just Rust is just like C, but with memory safety. They should add on at the end, Rust is just like C, but with memory safety, as long as you're willing to like learn a completely new way to deal with memory. Might not be smart enough to do it later, genuinely knowing when doing that sort of conversion. Yeah. Can't expect them to support everything from day one, but they could at least be upfront about it and say it's not just a magic language that does everything C can do, but it's also safe. They should balance that by saying you can get memory safety, but you're going to have to learn a new way of dealing with memory. And don't be deceived into thinking just because we use the same symbol, the ampersand, that it actually means the same thing as in C. It doesn't. It's completely different, right? There actually is a pointer under the hood, but it's what is the word? It's encapsulated within the type system. You actually can't just take a borrow and add to it like you can with a pointer. You can't make it point to something else, right? It's all strictly controlled by the compiler. Enforced memory safety in that is just wrong to say you don't have to manage. Yeah, you're managing memory just in a different way. All right, so let me try the idea that we will have two vertex buffers. One of them is instance bound. The other one is vertex bound. So yeah, I will end up passing two vertex buffers. This will be the vertex uniforms buffer, which doesn't exist yet. But let's make it exist. So now the model will have, in addition to the model's, oh, it won't go with the model though, will it? Really, we need another type called like model instance, don't we? Because the model, I might have a cube model, right, where the vertex attributes and index buffer are all both the same, and number of indices is the same, but then the physical characteristics could be different. So why don't I do that? Let's split model into model and model instance. I gotta slow down on the poor keyboard. So we're talking about splitting that out. Physical characteristics. And that gets translated into a buffer, right? Uniform buffer carrying physical characteristics to the GPU. So this is vertex uniforms buffer. Maybe I shouldn't use the word instance because that means something special in the graphics library, right? That's when we do draw instances. If we did the draw instances, then this might carry more than one instance, right? He'd have a buffer with maybe a whole bunch of different things in it. Maybe this should be plural, and this carries potentially the uniforms of multiple instances. That means that this has to be moved into something else. Yeah, why don't I do that? I might not like I might not end up sticking with this, but if we have a singular instance and they have plural instances, this might trip me up to have the type names almost the same but with an S. But we'll see how it goes. So an instance has physical characteristics, but instances carries physical characteristics of one or more instances. One or more instance, the GPU. I think then I would want to have like instances or models, right? Instances as an array of, actually, we might want to change the size of it so make it a vec of model instance of the instances. Alt Q, okay. Still have to be careful as raw pointers still have to follow Rust's aliasing rules. What happens if they don't, though? What happens if you alias them? It's all unsafe anyway. Are you sure you have to be careful? I think you mean like you have to be careful ultimately at runtime, right? But you don't have to be as careful at compile time. Like the compiler's not going to get in your way. You get undefined behavior. Yeah, but you get undefined behavior all the time in C. And it's fine. It's when the use of undefined behavior is restricted or careful use is enforced, I guess. And if you're going to do that, you're going to want to avoid unsafe, which means you're going to want to avoid pointers. So that's going to steer you towards the Rust's way of dealing with memory, right? Copies. Maybe instances actually goes with the model. Yeah, I'm starting to think this should go into here. Because why not? There'll be a one-to-one correspondence anyway. Yeah, okay. I think that makes sense. That should move into here. Geometry of geometry shared by all instances. Copies of the model with different physical characteristics. Okay, I like that. So the model has just the shared geometry and the shared buffer of all of the differences. The physical characteristics of each one are how big to make it, how much to rotate it in its position. Hey, any advice for a C++ beginner here? I'm coding a game at the moment. Sometimes you get really stuck. Did you get to master the language? I don't think you ever get to master any language. I have a mentor who claims to be a master of C++, but oh gosh, I hope he's not watching. I don't really think he really is a master. I think he's reached a certain level of mastery over it, but there are always things that you can get better at and learn. A tip to get better would be practice. I think that's universally true for any skill. So practice. Get a hobby. Stream it on Twitch and have other people critique your code live. Or if not streaming it, maybe get involved with an open source project if you can. Get people to review your code. I think you'll learn the most when other people look at your code and give you feedback. If you're just coding for yourself, you're going to be in this echo chamber of one, right? Where if you're reviewing your own code, you'll only really catch like mistakes that like don't agree with what you wanted, but you're not going to catch a mistake because something you actually thought you wanted is not the right or the best way, unless you get some other point of view, or if you review your own code after a long delay in which you maybe picked up learning elsewhere. Depends on which part you get stuck on as well. I think that in general, if you attempt to do something that's difficult in the context of what you know, you're always going to get stuck at some point. If you're not getting stuck, that means you're not challenging yourself. It's just what you do. What do you do when you get stuck? So what I do when I get stuck, I can think of three things. So one is you look it up on search online. Number two is you go to a peer, someone else who can review your code, and you ask them, hey, I'm stuck on this. What do you have? Any advice for me? Number three would be to take a break and then come back at it after like a day of rest. And you might have a different state of mind, and you might end up having a different approach to it, which is exactly what I'm doing here with this instances thing. I got stuck yesterday thinking, why is my ground rotating? What am I doing wrong? Took a break, came back and said, okay, I should search online, and also I should think about instancing and how do you have per instance variables. So just demonstrating how it works when you take a break and you come back at it with a slightly different point of view or perspective. Okay, so I'm going to have an implementation of model instance. And I think that's where we want to move the draw to, right? Actually, a lot of these. So let me just copy all of the implementation from model and paste it in model instance. Some of these are applicable to the instance, right? So scaled and at position apply to the instance. This does not. So we're going to remove this stuff. Right. Okay, so when you make a new instance, you don't need any of this stuff. Okay, I'm going to wait until it tells me I don't need that. Let me fix the compiler errors first. Right, so a model, you don't have a model at a position or scaled anymore. And you don't include the scale, rotation, or position when you make the model. But we do need instances. And we need a vertex uniforms buffer, so let's add that. Let me rename this first. Attributes. See, I probably unconsciously knew that I would have two vertex buffers because I had already put the word attributes in the name. Now that I think about it, it makes perfect sense because this is also a vertex buffer, but it's the uniforms. Right? You don't use instances, use manual batching. You find it easier and more intuitive. You could try that too. Both the menu and the grid are one vertex buffer object, manually batched. So you mean that every model instance has its own vertex attributes buffer? Is that what you mean? So I would basically draw a different bind with a different bind group for every instance. Doesn't uniform imply that it's not per vertex? Yeah, it's not per vertex. It's going to be per instance. So the way in wgpu that we just learned about 10 minutes ago was when we set up the bind group for this, we say that the step is instance, not vertex. Yeah, right here. So where is it exactly? thought it was the bind group. Is it the bind group layout? It's one of these. No, that's the uniforms bind group. Where is the bind group for the it's not the render pipeline. Where is it? Here somewhere. Is it in the description? I think it might be here. Yeah, this step mode, right? So we could step mode to instance instead. Now it's per instance, it's not per vertex. So yeah, I need to make a buffer layout for the uniforms. And its step mode will be different from vertex. It will be instance. Yeah, hi Ray March, by the way. Something vertex step mode. Yep, step mode. Hey Emily, how are you doing? Wish you could understand my code to help, but you can't read Rust. That's okay. But you're giving me a perfect segue to talk about my YouTube channel. I actually have I think it's 12 videos in a sequence that teaches you how to read and write Rust, if you're interested. I get a few pennies a month for it. Zoomed in font for stream? Oh, thank you. I learned from other streamers. And when I do watch other programming streamers. When I can't read their font, it's too small, it tends to drive me away. Unless they're really, really entertaining in and of themselves, then I don't need to see their code. So yeah, if you jump in to the stream, it's going to be hard for you to understand the code, maybe even if you know Rust, because I'm only showing you a small window, literally only 23 lines of code at once. Out of this file alone has 700. This needs to be refactored into smaller files. But because you can't see the whole program at once, and you're jumping into the middle of me writing it, it's going to be pretty hard to figure out what I'm doing. So my suggestion is, if you really want to know what I'm doing, ask questions. I can, you know what I should do is I should have ready to run. I should script this because then I don't have to type it all out. What's the name of this thing? wgpu playground. I can just run the program and then it's like, oh, he's writing a program that draws graphics, right? And he's got a cube and he's got some rotation going. Now maybe that gives you some context of what I'm doing. I'm playing around with a new to me graphics library called wgpu, and that's how we're drawing everything. But we also have integrated with it this traditional GUI stuff that is done in egui. So that's at a very high level what I'm doing. I'm playing around with graphics libraries in Rust. And I have a visitor. Hey chat, it's not just you guys that demand attention sometimes. There's other physical beings in the room. Just wanted to say hi. What text font rendering am I using? I'll show you. I'm using Code. Have font ligatures turned on. And I like to render white space. That's why you see these little dots. And somewhere in here, I think controls adding these lines at indentation levels, but I don't remember what it was. Spent some time trying to decipher what graphic specifications mean when they use the word uniform. We read to the conclusion that it's about values that either by design or accidental end being the same across all GPU threads of a dispatch draw call. That's a great description of that term. That's how I understand it too. It means that it doesn't change across some context, which means you can make it in parallel. So if you could parallelize the vertex shader, you could have every instance use the same value for this particular buffer because it's not going to change across all the vertices of one instance, right? Okay, instances, we're going to have that be empty first. Vertex uniforms buffer, we just filled it in up there, right? Okay, this contents, I don't want to create it with contents, so I just want to create it, right? This has different arguments, right? A buffer descriptor, not a buffer init descriptor. Copy that and then look for it because I used it down here, right? This is what I'm going to copy from. I want to put that here. Look at that. It's beautiful. So statically uniform would be something declared as uniform. Dynamically uniform would be just happens to be the same for all of them. Well, sure, but is dynamically uniform? It's just a coincidence, right? It's not something that has functionality. So does your current model conceive of different scopes? Because you could say something is uniform for the scope of one instance, or it's uniform for the scope of an entire render call, or it's uniform for the scope of the entire program. So I think that's what I'm trying to employ here. So my uniforms buffer is only uniform for one instance. So that's why we're going to set the step size instance in the binding. WGSL spec. In the shader, our declarations are for the scope of the shader. Well, it's not about scope. It's about where they're bound to, right? So vertex input is a structure that carries things that are bound to the invocation of each vertex. So these are going to be, I think that these are going to be different for every, these are not uniform at all, right? But you notice how they don't actually use the word uniform in the in the syntax? I'm using it in the name, but oh, actually they do have it here. Are uniform. So I probably have to change this, right? Because it's not going to be what they call uniform. It's going to be like per vertex. I might actually end up having to move this into here when all is said and done, right? That's probably what they mean by uniform in the shader is uniform for the whole render pass. That's a good point. Thank you for, you didn't derail me. You actually made me think that I need to be careful about the shader because maybe it's not what the shader considers to be uniform. Yeah, so this is probably also not true, right? Based off of what they're showing here in instancing, the instance buffer probably isn't declared as uniform. Let me see. Okay, that's the usage is vertex. I need to make sure that I have the correct usage. Yeah, so this needs to be vertex. Because that's what the tutorial says, right? I'm going to use the word uniform more flexibly on the CPU side, as long as it's qualified by the word vertex. Simple sample calls with implicit derivative calculation must be dynamically uniform at least. Ah, interesting. Does that mean like they could change, but yeah, that's what you said. They could change, but they happen to be the same. Hello, purring kitty. You want attention, don't you? Cat is over there. Okay. So far, so good. Follow the errors, I guess. Yeah, so we're not going to just draw a model. We're also going to draw an instance of a model or instances of a model. Actually, that means that these are for every instance, right? So need to have a loop for instance in model instances. Borrowed mutably. Right? So this is going to be instance scale. Instance rotation, instance position. There was a smarter way I could have renamed all of those, actually. But now that I've just mindlessly done it the more tedious way, no point going back. Spaces indentations, yeah. Some people like spaces, some people like tabs. Point is you understand the pattern. You can still guarantee it is uniform. I can guarantee it's uniform over some scope because it's declaratively so, right? We say that the step is instance, so that means it's definitely not going to change within an instance. Just trying to understand what you mean. Oh, what Raymarch said? Yeah, okay. Some operations in the GPU are just inherently per work group. I think it's all about scopes. So within a certain scope, if something is constant, it can then be shared by a bunch of parallel operations, right? Because you know it's not going to change. It doesn't need to be mutable anymore. All right. So we get the vertex uniforms, right? We got to store them back. Which is writing to the buffer, isn't it? Does this allow me to write into part of the buffer? Yes. So we should be able to write. Method fails if data overruns the size of buffer starting at offset, right? Because the size we set beforehand, right? Or did we? Where do we set the size? Does create buffer set the size? Yes. Right. So we have. That's going to be a problem, right? If I increase the number of instances, I have to recreate the buffer because it's going to have a different size. Unless there's a way to increase the size of a buffer. In OpenGL, you can resize the buffer anytime you want, but I don't know about OpenGL you can, but I don't know about wgpu. wgpu change resize buffer, I guess. How do you resize? Zoom in. You can't resize the buffer at runtime. Your two options are either to initially create a buffer that's the maximum size you'll ever need, or just destroy and recreate your vertex buffer each time you need to make it larger. Okay, good to know. Well, right now it's static how big I make, how many instances I make, right? So maybe what I just do is make it a constant. So that would mean that it's no longer a vector. Yeah, I need to pull these out into their own file. So I'm already having trouble finding them. Model. Yeah, if this is a constant, then we know its size, and so we know how big to make things. Has to be known at compile time. Okay, so that means I probably need to have a model builder. Okay, yeah, I have that. Should I put that into a common stuff like struct model constants? Come up with a better word later. Constants. Whoops. Wrong button. Don't save that. Hey there, Apollo I. How are you today? It's not Linux Mint, it's Ubuntu. I tried to run Linux Mint, but the problem is the physical machine is a Mac Studio. So I'm running, on top of that, I'm running Parallels. And inside Parallels, I'm running Linux. So because it's a Mac Studio, it's an M1 chip. It's ARM64 architecture, and I couldn't find an ARM64 build of Mint. So I found two viable choices for me were Ubuntu and Debian. I tried Debian and found that the libraries were all old and learned that they don't update. Debian's pretty far behind a lot of the time in updating libraries, so I switched to Ubuntu. We got an M1 and not a 2 because the M2 wasn't available when I bought this computer. I got it like earlier this year. Then they came out with the M2 and I should have waited. Okay. Well, the comment can go. There's no reason that we can't copy the comment everywhere. So it needs to be known at compile time. Don't I just make this generic over some n? That's how we do it, right? No, I can't use it with generics. Jeez, how do we do this? I guess it has to be vec. Because even the builder doesn't know at compile time. The builder only knows at runtime. So there's really no point in doing this. So never mind. Never mind, never mind. We have to keep it a vec, but I just can't resize it after I make it. Which is fine because it's not public. We'll just guarantee that in our implementation. New. You know what that makes me think is that does model render even need to be separate from the model anymore? Well, maybe not. Okay, where was I? Looking at errors. We make two model instances. It probably doesn't need the device anymore, right? But we'll get back to that. So this should be like models. Oh, what am I doing? Those are models. Those aren't model instances. I just need to split this out because there's the model and then there's the model instance. So model cube model dot instances dot push. Oh, this has to be mutable for me to do that. It is mutable. Okay. Let me just get rid of this now because we don't need any of these. So why don't I just make this default? I'll just leave it new and I'll refactor that later. Okay. Ground model is different from cube model. Ground model dot instances dot push. I don't know. It's not helping me probably because there's a error somewhere. Right, so this just ends there. That ends there. Follow the errors. Right, instances, 0 rotation. Okay. Needs to be mutable. Why does this? Oh, right, it does need to be mutable. We are actually changing the instances of the model. Probably shouldn't have it. So parts of these should be immutable, and parts of them should be mutable. So I'll clean that up later. Whoops. Sorry, I'm muttering to myself. That's self, that's model. Render, why can't it be mutable? Because I didn't borrow mutably. Draw. Takes an array of mutable references. Yeah, okay, that doesn't actually need to be like that, right? Oh, yeah, it does. So what was the problem with doing that? Because this is not inherently mutable? No, that's a slice of mutable references to. So what's the deal? Or model. Just remove that, right? And then that's already a reference. I don't need that. What's the problem? Double reference? Oh, shoot. So I need to do that. Is it because this by default does a yields references? Sure, but each reference, there's a double reference thing going on. So what is model? So I thought a single reference would, why is that not, why is it not like that? Or borrowing a mutable reference, right? So why can't I dereference that borrow and get to the mutable reference inside? Really? You can't do that? I can't have a slice of mutable references? I should be able to do that. There was some reason why you can't do that? Really? Hold on, I missed some chat. If I need you to requisition one, I need one for personal use though. Have you used the Unreal Engine? No, I haven't used the Unreal Engine. A Mac Pro with 1.5 terabytes of RAM? That's a lot of RAM. I don't think I've ever had a computer have that much RAM in it. You could like load the entire contents of my hard drive into memory at once. Can't do that because it would let you get two mutable references to the same piece of memory. Am I thinking about this type the wrong way? I was thinking about this as a type where you can't change the mutable reference, but it's still a mutable reference. So I should be able to go dereference that and get a mutable model. Otherwise, you could hand out two. Oh, I see what you're saying. It would allow you to break the rule about exclusive access. So this immutable thing poisons the rest of the type. They're not really mutable. Okay, so what's the solution here? Just to pass it in? But then it has to be sized. So then why don't I just make it of whatever size I want, n u size. And is that not how you do it? Is it the other way around? Syntax choices that are, this has to be const, right? Yeah. So now I can do it, right? Now I don't need to dereference that. Aha, I did it. It's just that this does that, and then with the power of generics, it works. Syrian, I did it without doing that. I just made it generic over the size of the array. So I whenever you can get rid of a borrow, do it. What's the impact of this? The impact is that I'll have a different implementation of draw for every array. Also, it has to be known at compile time how many I'm drawing, which is currently true. In the future, it might not be true, so I would what? I would change it to what you just said, a mutable array. Might as well pass a mutable slice because you already need to copy. I don't need to copy it actually. This is constructing it so that we can consume it down here in this loop. So I don't actually need to copy it. Not yet. In the future though, like, so this requires me to know at compile time how many models I have, right? And it requires me to like form an array in memory every time. So probably the best long-term thing would be to have it in a vector, and then we would pass a mutable slice to that vector. It would have to mutate it because the models are mutable. But then really, I don't want the models to be mutable in the first place. I want the instances to be mutable. And it's not really the business of draw to mutate them. So I need to refactor this. Hey there, Jimmy. How are you doing? Doing the same? No, yeah, you're right, Array March. Model Q. Q, well, vector or Q, it doesn't really matter because ultimately, I'm going to replace this with all constant, immutable stuff. It's just it's mutable right now because I haven't refactored it. I'm giving myself some work to do later, right? So does this actually build now? It's not going to do the right thing because I didn't put it in the bind group. Just out of curiosity and amusement, let's see what it actually does. It probably won't draw anything, right? Because I didn't bind the buffer to any group. It'll probably crash. No, it just works. How is that possible? Because I'm still using the old uniform buffer? I bet. Yeah, I'm still using that the old uniform. This one shouldn't exist anymore, right? Hold on. No, it's still used here. Okay, but I probably still have another copy somewhere else. It's this, isn't it? This shouldn't be here. I need to move the bind group, I think. Yeah, we don't want to use that buffer. Let's see what errors that leads me to. If we don't have that, then I can't write it here, which I don't want to. I want to put it into the model. This should be model, right? And then this index should be the index of the instance, but it's a buffer address. So I'm guessing it's, so if we, it's like if we have an instance number, dot enumerate. Oh, this would be like, uh-oh, 13 days left to update Chromium. Iter mute enumerate. What's the type of instance? Oh, I have it backwards. The offset goes first, and then that. Okay, so it would just be instance offset times the stride of the vertex uniforms, right? So it would be standard mem size of vertex uniforms. And then this whole thing needs to be converted to a buffer address, right? Yeah, so that as buffer. And that's not how we call it. It's like this, right? All right, we're good there. Literal arrays are stored on the stack, so there's no allocation. Well, there is allocation. It's just the allocation is on the stack. You meant dynamic memory allocation on the heap, right? And you're correct. But there still is allocation on the stack and then copying onto the stack and then reading it back and popping it up. So yeah. It's just where it goes is different. The queue mechanism, though, means you would have more control and know the size. Well, I'm going to sort of do that. It'll be a vector, though, not a queue. Uses a turbofish to get the size faster. Of course. Turbofish means it's very fast, right? We don't have a uniforms buffer. Why did we make one? Actually, I'll let the Rust analyzer tell me I don't need it anymore. Should put that in yellow because I don't need it anymore. Why didn't it? I'm not using this. Why is it not complaining about it? Is it because I haven't turned on the nag? What is that? Pedantic? This one? That'll probably warn me. I didn't use it, right? Okay, it's also going to tell me that there are too many lines. Too many lines. I do want to know about too many lines, but I also want to work on that later. Needs refactoring. Feeling we'll be adding that to a bunch of functions. That wasn't the reason I got a warning here. What was the reason? Oh, interesting. So this is infallible, so we didn't have to do that. Cool. See, you should always turn on pedantic warnings. We didn't need okay at all. Infallible. So then this always succeeds. Cool. I'm waiting for it to warn me that I don't need the uniforms buffer. Calling default is more clear than this. Oh, really? Okay. You just do it. Why is it? So I have to just copy from here? It really wants me to do that? Fine. Deal with that later. I'm still surprised that it didn't tell me I made these that buffer this bind group. I made it and never used it. Oh, I did. I did use it there. It's in the render pipeline layout. But the bind group itself, didn't it? Why didn't it warn me that I didn't use it? This bind group, I'm never using that. Is it because it has a side effect? Maybe that's why. Oh, no, we are storing the bind group. Oh, okay. Yeah, so I don't want the bind group either, right? We don't want this. But I didn't want to delete it right away because I knew I would need it somewhere else, right? Doesn't it go with the instance now? Or where are the other bind? What's the other bind group? Do we have a bind group? Guess we don't. No, we do. No, that's the camera. Okay, we don't actually have a bind group. It's a vertex buffer, so I don't need it. Delete it. Now it'll tell me I don't need to make it. Right. So we don't do this anymore. There is no bind group. We don't put it in self, which now it's going to warn me I don't need to make it, right? Yeah, unused variable, so we delete it. Yep, gone. And then we don't need the uniforms buffer. Okay, so we made a uniforms bind group layout we didn't need. But if I do this, then it'll say I don't need it anymore and remove it. I just hope I'm not deleting code I'm going to need later. Okay, cool. It's also warning me that I don't need... Oh, yeah, why did I pass this as a vector? Should have warned me about that. Interesting. So all of these things I could have borrowed. One at a time. Next is the view. Don't let Clippy bully me. I like bully. You think you Should always use default. I was letting it bully me. I shouldn't let it bully me though. This is how I let it not, I don't let it bully me. I put it back to what we think it should be, and when it gives me a warning, it's not for some reason. Why isn't it warning me now? I was gonna say we can just ignore the warning globally. Oh, because we have errors. It's gonna bully me in a second. It's just that we have an error. Errors supersede warnings. Okay, now we got warnings. And it's gonna say something about default trade access, right? So we don't agree with default trade access. Do you think we don't agree with that globally? Is this something that we would allow globally? When would default trade access be a good warning to have? It's when, exactly, when it compiles successfully, that's when we get bullied. You know it. But some of these things are good. Like, this is a possible overflow, right? It's like you're going from a 64-bit float to a usize, so you're going to lose some precision there, right? Possible truncation. So what we can do is we can, rather than like trying to, if it doesn't give me another alternative, right? I'm going to lose the sign, going to truncate, fine. Let's, okay, I'll just do one at a time here. It's still going to warn me, so that's interesting. It doesn't actually have the same kind of like, it is because of the certain warn. What is it again? Cast sign loss. There we go. I probably have this in a few other places, right? May truncate on targets with 64-bit wide pointers. Well, but that's just how it is. Possible. Yeah, we do want to allow it. Nothing we can do about that. Slightly lossy if we later change the type. Oh, yeah, we can fix it with F64 from. Rather fix it that way, rather than ignore the warning. All right, yeah, so that definitely should have been a slice, right? That's easy to do. We just borrow. So we're borrowing a lot of things in draw. Draw probably doesn't have the right responsibility surface, right? So that can go away. Okay. Have some errors? Where? Oh, and full tick host. FPS. Sure. I'll accept the loss of precision. We can't put it there. Okay. Lose the sign. Of course it's going to lose the sign. But yeah, it's because the resize, the width and the height are signed integers for some reason in full tick, right? So that's okay. Probably the same thing here. Yep. Warning free. Close all the things. Okay. So this is going to break, right? Because my shader is not picking up the vertex uniform buffer. Yeah, it's completely broken now. Yeah, the shader stage doesn't match the pipeline because of this resource binding is not available. So we got to remove the bind or change the binding. Okay, so I got to see how they did it in the tutorial. How do they get an instance input? They make a struct for it with different locations. Okay, they just added as another parameter. Got it. Wait, it has to be disassembled into pieces? Why? Parts of a matrix that we can use. Why did they disassemble it? Some limitation, right? Pipeline? Where do they say that there's, where do they talk about the limitation? Here we go. There's the step mode index, but why have, oh, is it because the format's limited? So I'll probably see that when I am setting up the buffer layout. So that would be if I looked under the description of the vertex. Implementation description. So probably the formats are limited, right? Yeah, okay. So there's no, you can't place a matrix. We have to put them in different slots. Okay, well, that's a unfortunate limitation. So we'll have to do the same thing. I want to just go ahead and make that description right now, right? Why did I copy the, there we go, copy all of that. Paste. Vertex uniforms. Maybe this would be easier if I said vertex instance uniforms. Now we're being precise about it. How did they do it? So they have the stride of the whole thing, and okay, so they're just using the size of the everything that came before as, okay, I guess I can do the same thing. That feels lazy to me. So instead of doing that, right? Goes there. Maybe I'll keep the position in there even though it's 0. So the offset of transform within vertex instance uniforms. So the whole thing there for the stride, and then the step mode is instance. And then we're going to have 4 slots, right? So And then these have to start at 2 because the other ones were taken. And then these are by 4, the largest we can have. Could you use self? Can I? Nope. Can't use self for some reason. Can't use generic parameters from outer function. Use of generic parameter from outer function. I think it has to do with that how that macro is defined. I could probably use it here though. Ugh. Yeah, I can use it there. So it means I probably could have used it down here too, right? So good point. Thank you, Mizzard. Mizzardix. I wonder if I can get rid of some of this boilerplate by using an iterator of some kind. Can I here, let me try to code it up. Just need to comment out the original. So attributes, it's going to be 0 through 4 map n to something and the borrow it. I'm going to need to collect. Can I collect into an array of whatever the type is? wgpu vertex attribute. Okay, and so the n is one of these. So it's this plus n times a standard mem size of cheat and look at what they did. The size of an array of 4 floats. The problem here. Oh, not a colon, a semicolon. No comma there. Slice of type cannot be built since slice is no definite size, so I want build that as a 4. Can I not collect into an array? Cannot be built. An array cannot be built directly from an iterator. I thought you could now. Can't? So what, I just have to cheat and use a vector and then borrow it? I mean, I could do that. It seems sort of weak, but okay. All right, it doesn't like a lot of what I just did. Look at that. It made that a block comment. Ooh, I think that's what happened. I think it's undo, get rid of that. That should not have been a block comment. Actually, I can imply the type there, right? Well, hold on. Before I do the type implication, I don't want that to be a block comment. Can I just save that elsewhere? Okay. A return value referencing temporary value. Returns the value referencing data owned by the current function. Oh, does this have to be static? Okay, the layout lives as long as our borrow of the attributes. That's the problem, right? It's not static. This needed to be static. Why does that need to be static? I'll follow the other one to see why did I make it static. Rate render pipeline needed to be static. Line descriptor. No, it's just some lifetime. Yeah, why can't I just make it generic over some lifetime then? That's what I think I'm gonna do. A. I always forget where to put that. It goes right there, right? Okay. So then I want to do the same thing up here. Oh yeah, because of the collect. Shoot. So it's not living long enough. Create a macro to avoid heap cut allocation. Well, I kind of think of macro as last result. Last result. Last. The term. Last resort. This should be 2 plus n. Didn't like that. Well, couldn't I just I need to get it into an array. That's what I need. So hold on. Go back a little bit. Let's go back to static, because why not? It could be static. It should be. I should be able to make a static thing, right? That this. What I really want is to make fixed size array of size 4. It says it's not implemented, but I thought that someone had figured out how to do that. So Rust array from iterator. That's an idea. Map an array to another array. How do I collect into an array? This is from 2014. I want a newer answer. Will it ever be possible to collect into an array? Requires const generics, which we have now. Aha. But it's not. Like we make it and we do a for in, we just store into it. In it. Try to ask ChatGPT. I don't. How do you use ChatGPT? Don't you need to sign up for that still? I don't write a crate that does exactly that. Yeah, we could just create it and store it, maybe. You think it's a fallible operation? It shouldn't be fallible though. It shouldn't need result. Unsafe. Resort to unsafety. Okay, so I guess it's not an easy solution. So I guess that's why in the tutorial they didn't try to do it that way. That would be nice if we could do that, right? Otherwise I just have to repeat it, which is like this 4 times. Yeah, but Sarian, this is known at compile time, so it should, if it was a little smarter, it could figure out that that size is the same as that. I guess that's what I'm saying. I try the other way with mapping an array. So what do I get with that? Not an iterator, so it's like iter into iter. So you still can't. No collect with array. Yeah. Whatever way we do it, we can't collect. And why do I have a 4 there? Okay, well, let's just abandon that then. So this just goes back to this. Woohoo! We can't do it. Zero. Here, I'll be what's the word? I'll be passive aggressive and make it look like I should have been able to do it with an iterator. Forgot here to put this back in. Plus n, where n is 0. This does feel like I should do it with the macro, right? That'd be another passive aggressive approach, saying I'm going to do this with the macro because this is known at compile time, but it won't let me for some reason. Okay, fine. I won't add then. And I won't do 1 times. And I won't add 0. Flippy spanking me again. Okay. Standard array from function? Is that a thing? It'd be useful to know which of my tabs is, I think this is it, right? So, which of my tabs is the Rust documenter? From function. Actually, that would work, wouldn't it? But it's not a const function. That's the problem, right? Am I going to run into that? This is not a const function. I need it to be const. I could try it though. So the idea would be we would have some like make array. I don't know. Actually, it can just be a closure, right? It gets the n as an argument, right? Yes. So I shouldn't have deleted it. Can I undo and get it back? I think I can, if I'm careful. Yes, there it is. There's my closure. Then I can do a redo and get back to where I just was. Then I can paste my closure. You're saying I should be able to do an, how do I reference it? Standard array from function, and then do that? Okay, it's probably because it's not a const, right? Type annotations needed. Can I infer the value of the const parameter n? Yeah, so I need to tell it that there's 4 of them. I do that again, it's like with the turbo fish. It needs all three, but the other ones can be implied, right? So n something, or t something, and t for f, underscore for underscore. Yeah, cannot call non-const. That's the problem. I kind of knew that we would get that. Cannot call non-const function from function. Because the whole thing is a constant function. But let's say it's not a constant function. I think we still have a problem, right? That it cannot return a value referencing temporary value. So it's not, it gives me an array that's on the stack. Again, right? It's not static scoped. Maybe create an array with 4 vertex attributes and then map to change shader location. I think, don't we still have the problem that we're going to return a temporary value? This has to borrow for the static lifetime the whole the array. So the array has to be static. Yeah, I don't think there's any way out of this. There are two reasons we're trapped. We're trapped because we want it to last static. So I'd have to have a leak if I allocate it on the heap. And it can't be on the stack. It has to be constructed in the result, really, right? It has to, well, it has to be constructed in the data segment. It has to be completely constant and known at compile time. And so we can't call any function that's not const or that creates a value on the stack or the heap. Yeah, it would be nice if we could. Maybe I hold on to my nice closure. Put it here. Be nice if I could do that and just go back to this for now. Spending too much time on one problem and I don't get any progress, right? It's never used, but we will fix that. Hold on. Why did search not find description? Why didn't it find that? I don't know why it didn't. Okay, anyway. We need to add it here, right? Vertex and then vertex uniforms description. So it just becomes part of the vertex state, right? Which tab? Which tab am I on? I don't know what tab it was on. Oh, one of these. Did I lose the tab I was on? I think I might have closed it. Oh no, this is it. The last one. Okay. Yeah, so that's what I just did, right? I added it to buffers. And then how do I use it in the shader? Oh, I have to make a... Did I make a buffer? Not there. I made it somewhere else. I have to do and make sure I do a set vertex buffer. I did do that. Okay. Okay, so yeah, then I have to do the reassembly of the matrix inside the shader. So yeah, so it can't be a matrix anymore. It has to be a vec. Is that how it's done? Okay, but signed locations, just like the vertex input. Makes sense. Actually, I need to add 2 to all of these, right? And this kind of goes sequentially after the attributes. So vertex instance uniforms. There's no group or binding. There's no uniform variable. It's now here as uniforms. Right? Yep. Did I do the thing and have an extra comma there? Nah. I need to do the reassembly. Why type it when I can just copy it? I wanted to call it transform, so do this trick. Okay, and then I just do transform. Okay, now what do I get? Does vec try into to convert to array? Yeah, but then I still have the problem where vec stores on the heap. I can't store it on the heap without leaking. Why is my Rust docs logo all chubby? Probably because I'm zoomed in. Which one? This one? I'm guessing because I have the zoom level. No, it's zoom 100%. I don't know why it's chubby. Good question. I don't know. Cleaner than GLSO solution where they allow matrices but have them consume one location per column. Well, we're sort of doing that, right? We have one location per. Is this row or column? We're kind of doing the same thing, right? I think the way did it was attributes were passed in from outside. Are you saying oh, you're saying GLSL does this for you, this fragmentation and reassembly. You can declare it as a matrix though, but they still consume like 4 locations. I see what you're saying. Yeah. So then actually I'm kind of the opinion, I kind of prefer to see if we have to consume locations, which are resources, I kind of like seeing how it's explicitly done there. They have a special case for locations. But then you have to remember it's 4 wide and not just one location, right? Yeah, I was going to run this and see. Oh, did it already panic and I just didn't notice? It did. Missing the copy destination flag. Oh yeah, I got to set that, don't I? They probably have it here and there as well. Or did they only set it once? When they set it up. Oh yeah, they only set it once. That's why they didn't bother with it. So, but I need to bother with that. Where was that again? That's when we create the buffer. So that would be in the setup for the model. Yes. So it's here, right? I need to add a usage. Copy destination. Oh, we did it. Look, cube is rotating, ground is not. Yay. The ground is like a toxic green though. I think it might be time for me to turn off the sRGB thing. Because the problem I had was I made it toxic green because I tried to make it brown and it looked gray instead, right? Where was that? Ground. The ground vertices, right? These colors. Let me try to put it back to what it was. Still have that tab open. I tried to pick this color of brown and it didn't look right. I kind of want to see, pick from this. Let's use this. I can't. It's actually an image and nothing for me to copy from. That looks a lot darker than these values suggest, doesn't it? This looks a lot darker than it should. That color can't be right, can it? That can't be right. Eyes are deceiving me. Can I inspect this? More tools. Developer tool. There we go. I'm going to do the color dropper thing. Where is it? Where was the button to like pick something? Is this one? Select an element to, yeah, here we go. I want that element. What's its color? What is EFDECD? That just doesn't look right to me. No, it's not right. That is not the same color. I'm sorry, but that is very much gray. So what the heck? Is there something drawing on top of it a color? Wow. There's a lot of stuff going on in the CSS. Looking for that actual color. Don't see it anywhere. Yeah, that's correct. That color matches, right? That color matches that. But then when I pick this element, that's obviously not the same color. Yeah, how did they... Okay, I don't know why I'm obsessing about it, but I'll just use MizardX's color. It's like that color's completely wrong. All right, so can't do hex conversion in my head. I'm gonna have to fix this. Might as well just do it now, right? As F64 divided by 255, 0x. Oh, thank you for giving me the decimal. I appreciate it. Much less painful that way. 35. $61. Maybe this just looks right and I don't have to worry about the sRGB thing today. It takes a while to... I mean, I don't know if I'm like that color. Wanted something better. Just turn off. That's more like that beaver color, right? I want something like poo. That's just not right. This looks more correct. So 4331? Or should I just try turning off the sRGB? Let's see what it looks like first. sRGB. So instead of doing all of this crap, right? We'll just pick a format. So this is what type? Texture format. RGBA8 unorm. This one. Well, really it can't find that type? I don't want to import the variant, I just want to qualify it. Okay, I guess it's going to make me type it. wgpu texture format. Oh, it's here. All right, now that warning should go away and maybe the colors look different. See you, Raymarch. I have to go soon too. I gotta start working. Okay, well, I'm not a fan of that color. It is darker now, but maybe if I made the background not so dark blue now. That's my clear color, right? So it would be where I do the render pass, where I do the draw. Here we go. Let's make it blue, but not too blue. Hey, 85 filter. Wait a minute. Was your name always 85 filter? My memory is like tricking me out. Okay, that's not light enough. Let's add some green to it. One and only 85 filter. Okay. The 85, I was thinking, like, that's not the right number, is it? I guess it is. Any more blue? More blue. I want sky blue. Give me sky blue, please. There we go. That's better. So maybe I do want a green ground. After all, don't I? Nice sky blue. I can play around with in the shader to make an actual skybox that makes it look nice later, maybe. You know what I should do rather than having it 4 times? Is just, I should just have like ground color. I need to get better at like thinking of that ahead of time. Like, I don't need to be repetitive. I can just declare it once. It's of type what? This type. Equals. Let's just make it green. So R, no component. G, not completely 1, maybe 5. And B, no component. Okay. Is it going to complain about having 4 copies of it? No? Is arrays are copyable? That's nice. Ah, starting to look more realistic. Good timing too, because if I have to go to work soon, then having fixed the problem of the spinning ground and having the colors look better is good prep for like the next stream being completely totally different, right? What I wanted to do was introduce the physics engine. So rather than just like having this cube spin over time like it does, have the rotation controlled by a physics engine, give the cube a rigid body and what is it? What's the other term? Like the ground is rigid, the cube is rigid, but also the cube has momentum. Whatever it is in the physics engine that they call giving something, you know, velocity and mass and all that, and then have it drop onto the ground and bounce. Wouldn't that be fun? Do you have a dark mode extension messing with stuff? Could be. I didn't think I had a dark mode extension, but Chromium does let you set that up in the settings, right? Theme or something, right? Surprised, like, what's this work? Huh. I don't know. I think that's it. I can't remember where was it under appearance? don't know, somewhere here, like there's, I think it's like using the systems, like whether it's light or dark. Okay, now I've changed it and don't know how to get it back. Oh well. Anyway, I forget. I don't know where it is. I'm not going to worry about it. Hey, look, we have a special guest. Ita. Yeah. This is a good stopping point for the coding, but I guess I can spend a little bit on refactoring. I got some time. That looks good to me. Okay, let's move stuff out to other files. So we can have a file to hold on to the vertex type, I guess. It's actually vertex attributes. Let's go ahead and rename that now. I said geometry shared by all instances. This should just be geometry per instance geometry, right? Or per, and this shouldn't just be geometry. This should be this is really vertex information. This is per instance vertex information. Copies of them all, different characteristics. I don't think I actually need to say that. I think that that is all I need to say there. So we have the model hits instances, and then with comments, we're sort of dividing that. Some of them are shared, and some of them are per instance. So basically, these have constants, and these are loaded every frame potentially. Okay, I like that better. Okay, I was surprised that it didn't warn me about these being in a different order now. Like, doesn't it usually want these to be declared in the same order? They weren't really in the right order to begin with, were they? They were. Well, except for that, it really kind of goes there. In my mind, it makes more sense to have the index buffer and num indices be together. Yeah, okay, fine. I'm wondering if I should call that per vertex buffer and per instance buffer. Lost my place. Like, instead of vertex attributes buffer, attributes isn't really the right word because this is passed in per attribute also. It's just getting the same value every vertex. Yeah, let's rename that to per vertex buffer. And we'll call this one oh yeah, you can scratch my chair. Yeah, that's totally normal. Hello. Gonna lick my face? Taste the human before biting. Ow, ow. I'm getting bit. Per instance. So how much should I That mess with me. That mean no blood. per text buffer. It's per text buffer might not really be the right name, right? Think of a better name. I think I need to think on that. And I probably should get going, so make sure that this still builds and runs, and find someone else to raid. Let's see. Okay, today how about we raid Auroral Games, because I already raided the other two people I see streaming. I already did very recently. Okay, everybody, hope you enjoyed. I don't know if I'm streaming on the weekend or not. I haven't figured that out. So I may or may not be back tomorrow. We'll see. But should be back on Monday at least. So I'll see you guys when I see you next. And we'll work on getting this cube to actually have physical properties, all right? Hope to have that physics engine going integrated soon. Shouldn't take too long. And then I got to figure out what I'm doing next. But anyway, let's see. Am I going to get an ad if I go there? Yes, so I got to wait out the ad just a second. 30 seconds of ad. Ah. I'll go ahead and hit the button, and I'll just be watching an ad for a bit. Okay, see you guys. Bye.